All right, welcome back, yo. It is me again. Today is Friday, and there's a all company training, so you know what that means. Time to get lit, cut loose with some good old fashioned Google slides. Today, we're going to be deep diving into targeting with the Alertus solution. It's a safe assumption that my sales folk recognize this slide, and by recognize, I mean have had to present this slide more times than you'd want to recount, and are likely having a still in Saigon moment upon having to see it here. These are primary value propositions, and explaining any one of them at any depth at all is going to go straight into a conversation about targeting. Single point of activation for everything. How? How does it know what to do when you activate? If my sprinklers and my PA system are on the same single point of activation, how is that not a problem? An integration. If it talks with everything, again, how? How can you tell my access control system to lock the right doors? How can I tell my digital signs that display the lunch special to warn of tornadoes? These signs are as dumb as the rocks that were mined to make them. Talking to them is no easy feat. And then finally, you have filling in the gaps. How do you determine where people are not currently being reached? And for that matter, how do you decide who needs to be reached in the first place? All of these lead straight into the same big idea. What do we target? And how do we do it? I'm not going to sugarcoat it. This is going to be somewhat of a lengthy training, but this length is necessary for two reasons. The first is that the topic is broad. It relates to every single client that we serve, from the smallest church to the largest federal entity. They need to know when an alert is sent, that it will be seen by the people who need to see it. Sometimes this is central to our core offering, or excuse me, something this central to our core offering must be understood thoroughly if it is to be messaged reliably. The other reason we'll be here for a while is the complexity of the topic of itself. Alertus has existed for 20 years, and over that time, sales engineering has worked in parity with their engineering, both software and hardware, to create an enormous array of integrations. These integrations are predicated upon different principles and therefore operate differently. We're going to be exploring those principles to understand what we can and cannot accomplish in targeting. So get cozy, it's learning time. We're going to start with our first principle and establish the language we'll be using to identify our targeting challenges and, by extension, how we will solve them. For our purposes, targeting means deciding who receives an alert when it is issued. In some cases, the answer to this question is very simple. Everyone. Every possible person we can reach by any and every means possible will need to know this information. In most cases, or most organizations, however, the answer is more complicated. There will be people we can reach for whom this message is applicable, and there will be others for which it would only be an unwarranted interruption to their day. Their goal with targeting is to define what criteria separates those who need to know from those who don't. In the vast majority of cases, the criteria for selecting an audience of an alert will settle comfortably into one of these three categories. First, we have our geographic targeting. This can be as small as a single industrial workspace or as large as several counties. If your primary concern is based on physical proximity to a hazard, like a tornado, active shooter, or aggressive wildlife sighting, again, thanks for looking out for me about those bears, Peter, then geographic targeting is going to be the criteria you will use for determining the targets of your alerts. Next, we have facility function-based alerting. As the name implies, this is used when there's information about an alert is only relevant to a particular kind of facility. You might use this for targeting a message about extreme heat advisories with revised hours to only manufacturing plants and warehouses, but not to climate-controlled offices. Another instance might be messaging air extreme wind advisories to maritime recreational facilities, but no other recreational facilities. Targeting by role is where we can have the most fun. There's some obvious cases that jump out here, like alerting security of a potential threat or IT of a potential outage, but there's so much more that can be. The term role does not have to be taken literally. It can apply to any criteria we use for differentiating between machines or their users. This can target machines used for processing orders to display a banner about shipment disruptions, or it can target only individuals above a certain security clearance. Again, the term role is sort of a blanket for anything differentiating these specific machines or users based off of their individual role in a process. All right, so now we have some clearly defined roles. The Alertus server needs to be able to distinguish between the geographic region, facility function, and human operators of all devices connected to the Alertus system. This begs the question, what are all of the devices that can be reached by the Alertus server? Much like defining our targeting parameters, this requires some additional exploration. Let's look at an example. We may start with just Alertus desktops. You can see we have our Alertus server. Those 3 stacked disks there are the symbol for a server, and a bunch of Alertus desktops. The network topography is a little wonky, but that is fine. This is lovely. Everything communicates the same way and acts the same. Then we add some alert beacons. Okay, alert beacons have a location, and that location has a function, but they don't necessarily have a human operator. Things are getting a little bit fuzzier. Right, peripherals. So the cable run of a peripheral could go through a wall. We might have the alert beacon itself in a hallway and the LED marquee connected to it to the cafeteria on the other side. That is about the same location, but spans 2 different facility functions. But this is not irreconcilable. Maybe cafeterias only display the alerts that are silent and do not use flashing lights. IT would still be able to use the LED screen of the alert beacon, but it wouldn't be as disruptive. We can work around this. Okay, yeah, that is true. We could use a dry contact closure to signal a lockdown to every door in the access control system. I guess that makes all of those doors fall under the term devices that can be reached by the Alertus server. That could get a little bit more complicated depending on what tools we could have access to on the control system side and how many alert beacons are tied to it. And okay, VoIP. So clearly we need to establish some more terms about these devices before we can discuss how to actually apply these targeting schemes. It is not cut and dry. The easiest distinction is to think of this in terms of integrations and native devices. In both cases, we're going to be applying the same goals. We want to be able to define our targeting groups based off of specific criteria. Again, ideally, that is geographic function, role, and who's on the other end of the thing. But what we want to do is create targeting groups based upon those criteria. Unfortunately, though, that is where the similarities between these 2 camps end. For the purposes of targeting, integrations are the easy part. We have a ton of them. This is an incomplete list, but an accurate representative sampling of integrations. When we talk about integrating with another service, it does not necessarily mean that it is another mass notification service like Rave or Everbridge, although we do integrate with them. It means that the endpoint we are connecting to is the one that is going to handle the actual targeting for those devices. I'll explain it with a couple of use cases here. So right here, when we integrate with an organization's internal email server, we tell it what mailing list to use, but it is the email server that is responsible for knowing who should be members of that mailing list. E.g., the Alertus server does not have a way of knowing that the email server's system admin's emailing list is a current and complete list. It just tells the email server to send the message to that mailing group. Likewise, if we're integrating with Avaya or Cisco, we will pass in targeting groups or paging extensions for the VoIP service. But the onus is on the VoIP server to ensure that the members of those groups and the targets of those paging extensions adhere to the intended targeting parameters. So in the Alertus server, we might call a group of paging extensions called conference rooms, West Office. But it's the VoIP server managing those extensions and their devices. All we know from our side, the Alertus side, is the group that we're calling. VoIP handles the membership of that group. It is the same for all of these integrations. Everything from who is permitted in a private Facebook group to what devices are monitoring a cat feed, these are all controlled outside of the ambit of the Alertus server. This is both the weakness and the strength of our integrated partners. The weakness is that we do not have direct access to the parameters used to create the target groups, at least not directly in the Alertus console. The strength, however, is that we can use the specialized targeting methods inherent to dozens of different services. We can leverage the data entered into Outlook by HR to target email by role. We can use the schema of extensions that have been already established on the VoIP server to know that all numbers starting with 3 are manufacturing, or that all starting with 5 are assigned to offices. We can trust that when we use a webhook integration to post to the weather alert Slack channel, that the right people are in that channel. The Alertus server does not have to put them there. So the extreme benefit of our integrations is that when we talk about targeting, what we can say is whatever distinguishing criteria you have already created in that service, we will be able to leverage to make use of the existing structures, not reinventing the wheel, not spending extra man hours, using what you already have. One might argue that this is another form of filling in the gaps while making use of what exists. So to summarize, when we send an alert to an integrated service, we will know the name of the group we are alerting or something comparable, but we will not know what the group contains because it is managed by the other service. As such, these integrations do not care about the groups we make in the Alertus server itself. They have their own groups specifically designed for their own endpoints. Now, as we move into the idea of these groups that are native to the Alertus server, we look at our native devices. All the information about these native devices is sent directly to the Alertus server. By induction, that also means any information we would use as criteria for grouping is also being sent to the Alertus server. What that information is will be different based off of what device is reporting in. As we said, an Alertus desktop will be able to tell us who the operator is, but an alert beacon will not. Before we go too deep into these woods, though, let's tie up our first chunk in a nice bow. Our goal is to be able to selectively target all of our devices based on their location, facility function, and human operators. We make groups based on that criteria, so we can target only the devices that satisfy that criteria. What information we have, and by extension, how we manage to put those devices into groups, is going to be different depending on the device. To that end, we use two broad categories: integration targets and native targets. Integrations do not use their groups. They will always go out to the target specified on the alert service. The targeted service knows what devices are in the group and why they are there. If the alert service is not monochromatic orange, as you see here, you can assume this is the way that's going to work, which is to say that it is an integration. The opposite is true of alert services targeting native devices. These alert services are monochromatic orange and will only target devices within the group or group specified as the recipient of the outgoing alert. These groups are going to be going into in a little bit more detail later. There is, however, one wacky exception to these rules, and that is our mobile recipient app. The mobile recipient app breaks all of our rules. It is an app we natively developed, but it does not check in every 20 seconds. That would be a lot of expensive cellular data. Also, it is the only case where group assignment is handled on the endpoint itself, which is to say the cell phone, not the Alertus server. Mobile users decide what group they are a member of from the options available to them. And the final strange bit, you'll note that the mobile recipient app actually has two alert services, a gray one and an orange one. The gray one works like an integration, which is to say it will ignore the recipients you have specified and target every mobile phone that is registered on your server. The orange one will act like a native device and only send the notifications to devices that are a member of at least one of the groups specified to target. So now that we have endured the world's longest slide together, you probably have a decent grasp of the underlying concepts needed to explain a primary value proposition. At this point, we don't have all the details, and honestly, we don't need them. The goal of this training is not to make you sales engineers, it is to get you comfortable enough with your targeting to be able to talk about it with clients. And this, as you likely can now see, presents a challenge. How in the world would you convince any human you are not paying to listen to you, sit through all of this explanation, to even consider what you have to offer? The answer is, unfortunately, that you can't. Not really. No one is going to want to hear all of it. Any given person is only going to want to hear about some small part of this beast that they actually care about. And so that is exactly what we will learn to do. Now that we have our grounding in targeting, we're going to look at a few ways to frame this information so it will make sense to the different people interacting with the Alertus system. And who knows, we may even learn another few details along the way. We're going to be looking at 3 different perspectives. First up, we have administration. We will charitably call them pragmatists. They're not terribly concerned with the finer points of targeting. Their primary purpose of the business is to generate revenue, and time spent on emergency notification bells and whistles is time not spent on their core competencies. They want a broad overview, and they want to know that they don't have to spend more money on buying things they already have. They have a checkbox that needs to be checked, and they need to know that this is the fastest way to change that. This aligns pretty directly with their value prop of filling in the gaps. This is primarily for facility level notifications. The second perspective we will be looking at is that of an emergency manager. These are the people actually eating the dog food. They care about it. The system has the potential to facilitate their existing standard operating procedures, and if possible, make it easier to do their jobs. Can it simplify how many things they need to log into and what they have to do once they're logged in to make sure everyone gets the information they need? In short, they care about how this can be the single point of access. And last but not least, we have IT, for whom this will be the latest iteration of reinventing the wheel. They need to know details. How exactly is this system going to exchange information with existing infrastructure? What network and firewall changes are going to be made to accommodate it? In short, how is it integrated? Crazy how that works out, right? Man, someone put a lot of thought into value alignment on this presentation. Oh, man, you shouldn't have. I mean, it's totally warranted, but you shouldn't have. All right, administrators. The main thing that needs to be conveyed to administrators are that when we talk about targeting, we are not just referring to who gets the message, but also by what means that message is received. The Americans with Disabilities Act refers to the modalities of audio and visual alerting. This means the current system may target the correct area or personal notification devices, but lack the criteria required for comprehensive alerting. Another great source is the National Fire Panel Association Fire Code Standards. Although not as legally binding in all circumstances, they are damned good guidelines to be familiar with and define alerting in terms of layers of targeting. So these are the ways that we are able to target on each layer to ensure that everyone gets an emergency message that is intended. You see, we've got a facility-based, number 1. And number 2 is their enterprise or network. 3 is the wide area, and 4 is mobile solutions. So let's look at this. A facility-based targeting, these are generally entire buildings, nondescript. If you're pulling a fire alarm, if you're doing a fire panel, everyone in that building is going to know. Big outdoor LED marquee signs, they're going to know. Same with piping through audio. This is a not subtle, everyone in this building knows. A facility-based solution. Then we have enterprise and network-based. These are significantly more tailored. You can hit individual signs, individual screens or phones, or use these speakers in separate hallways or specific spaces. The network-based solutions are used for targeting more generally role-based, whereas facilities are a generally more geographic one. We also have outdoor wide area solutions. These are going to hit everybody in a very wide area, but with just the audio. So when we're thinking in terms of layers for admins, we can say, who do you need to hit? Does it have to be everyone in the building? Is it just specific people? Is it entire campus? And they'll say, well, what about people off campus? And you say, I got you, fam. Mobile solutions. We have people who sign up to these groups. We can send them out to individuals regardless of their physical presence in any of these locations. They don't have to be by their VoIP phone. They just have to be holding a cell phone. So using these 4 layers, we can pretty explicitly explain to the administrative group what it is we're trying to accomplish with targeting in these broad, simple categories. So basically, when you're talking to a client's admin team, you boil it down to this. A message that cannot be received by an audience is pointless. The American with Disabilities Acts and current NFPA guidelines indicate what is required for emergency messages to be received in emergency situations. We need the modalities required for crisis conditions. Not all emergencies are the same, however, and some require more nuanced or targeted responses. If an employee is poorly handling their unplanned separation from the company, that might call for the same speed of response as a fire, but with significantly more discretion, so as not to cause undue disruption and chaos. So we can target as wide as entire campuses or as small as individual phones of security personnel. And last but not least, we are experts in filling in those gaps between what you have and what you need to be safe and compliant. We pride ourselves on the sheer breadth of integrations we accommodate. The goal here is to tie together everything they've got first and add in anything else that they need after. Because let's be honest, if they were happy with how things are now, you wouldn't be talking with them. What they need is a change of how things work. And that brings us to emergency managers. These folk are the ones that will be working directly with the system under the duress of emergency situations. They care about what can be tied into the system for a single point of activation, which is to say, they were doing this job before Alertus and set up a whole bunch of systems exactly how they like them. They just don't like how many steps it takes to send all of them out. What they care about is that their existing work will not need to be redone and that any new functionality can be easily grafted onto the existing paradigm that they've established. Critical messaging here is to reassure them that their integrations make use of the targeting already established in other systems, in addition to any new targeting groups established in the Alertus web console itself. Allow me to demonstrate. These are the most common methods used to establish the initial criteria that is evaluated to create targeting groups. Again, remember, when we're creating these groups, it's about identifying a criteria that separates what we want to target from that we don't, and then grouping based off that criteria. Out of these common methods, these are the ways to use prior existing groups and organizations in the Alertus web console. Oh, well, you look at that. It's all of them. Let's talk about that. IP address. Organizations will often use something called subnets to logically divide up their network for the ease of knowing what traffic is coming and going and from where. These same logical subnet ranges can be used by us to know where a given machine is based on what it is connected to in the network. Virtual machines have IPs too, sort of. They make them up. We can play along, though, with these made-up IP addresses via a check-in variable. BSSIDs is the identity of the access point a device connects through. This is similar to an IP address in function, but is defined by the identity of the hardware rather than the range of IP addresses it's servicing. So this is basically targeting based off of router or whatever switch they've got in the closet. Not a problem. Device names, these are fun. They're set once at the initial check-in to the server, so they're great when you want a static assignment to an endpoint where other things may be static. This is often tied to a computer name, but you can get real wacky with it. But we can go one step further still. What if we want the variable we're looking at to be checked on every check-in instead of just once when naming the machine? Well, you're in luck. This is exactly why we have check-in variables. For instance, you might check the current user's keyboard configuration to see if it's set up for English, French, German, Spanish, etc. Then pass that information to the Alertus server. Congratulations, you just used a check-in variable to group devices by the language logged in of the user. But we don't have to stop there. There's no brakes on the check-in train. Typically, these are managed by GPO or group policy object. But if you're using an enterprise solution to manage what gets pushed where and when, you can be pushing variables dynamically whenever you want that are then picked up by the desktop client. Remember, this variable is reported on every check-in. So you have effectively just created a bridge between your enterprise management solution and the software for Alertus. You can throw down a text file to be evaluated, and bam, every 20 seconds, that will be used to determine what group the client is in. You want a client in the chartreuse group before noon, and the taupe group after 1, you got it. Just set up your file pushes in your software, let FTP take the wheel. LDAP, most commonly through Active Directory or AD, is an absolute classic. Larger orgs will already be tracking the roles and permissions of their users via centralized service. This is why the same person can use the same credentials to log into many different machines in a college campus, for instance. The groups created in LDAP are called operational units, or OUs. And whatever is already there, we can use for targeting individuals. But not every organization uses LDAP. So again, we have options. A .csv stands for comma separated values, which is basically a fancy way of saying a spreadsheet. If you have literally any other way of organizing your users and their accounts, you can likely export it to a CSV and use a simple script to format it. A bit of text sorcery using Task Scheduler and a REST API, upload it to the server, and bippity boppity boo, you're off to the ball. But maybe you don't want to just talk to desktops. Maybe you want to talk to other hardware that has no idea what Alertus is or why it should listen to it. Like, say you have your door locks configured to an access control system. You can use Alertus to pass in information like the closing of contact closures. These are the dry contact closures on alert beacons. Then use a specialized device-specific grouping of the access control system to decide what to do with the input and what to target. Alertus doesn't have to be a control freak. It can provide the information and trust those other groups. While we're at it, if you're using Alertus to consolidate other mass notification services, then good news. When you target that service through Alertus, you can still use groups and targeting as though you were activating directly from that service. That is some friendship is magic level integrations right there, but we're still not done. You see these other points down here? Webhooks, man. Webhooks. The ones we're looking at today are talking through existing channels as though you are human in that channel. Why would we want these? Well, say you want to alert people, but there is no consistency in your IP subnets, nor in what access points service what locations. Say there is absolutely no system of managing these machines at all. We don't use LDAP. We don't use group policies. Our devices are named by pulling letters out of a Scrabble bag. There is literally no framework whatsoever. Even then, in whatever shoestring and balloon animal-based system you are using, if your people can be in the right Slack channels or Google chat rooms or Microsoft team rooms, it's unclear. At any rate, if your people can be in the right chat channels, they can still receive the right emergency notifications. And I know what you're all thinking. That's a pretty low bar, but it's not even our lowest form. That would be our mobile app. Even if you don't have the level of organizational structure to have people be in chat rooms, then not all hope is lost. The mobile recipient app lets your members in your organization sign in with their phones and choose what groups to join in. You can decide what groups they have permission to join and set passwords for groups, but there is no centralized responsibility whatsoever. You don't even have to moderate a chat room. It's up to the stakeholders to join the appropriate groups. So regardless of if you have a well-regulated IP address subnet ranged structure, if you've got check-in variables for your IP addresses, if you're using targeting by closet or fancy namings, if you're using GPO to push around variables or an enterprise solution to distribute them, if you have LDAP or any other way to group these people, you have a way to target them. And when you're talking with emergency managers, this is what you need to convey. When you're sending out an alert, there's only a few things they'll need to know. First is the message they're going to send. You can leave some variables in there, the time of sending if you want, but you can just have it be complete as well. What we care about for this training is going to be the targeting, which is these two sections here. Green is one, even if it's split. First is the types of devices that are going to receive the message via alert services. We already talked about the orange and gray ones. So this might be devices native to Alertus, or orange, like Alertus desktop clients, IP speakers, alert beacons, HPSAs, the like. And you can choose to target other systems, although through an integration. Targeting the integrations is baked into the integration itself. So you might have one Rave alert service for North Campus, a second one for South Campus. And if you're using VoIP integrations, you may use a different service for different paging groups. You can create as many alert services as you would like, and you can use them to target as many different types of devices and services as you would like. After you've selected your alert services, you will filter who you would like to target. Keep in mind, this filter here only applies to native targets. So for instance, you say target Alertus desktops, but only those in the North Campus group, or target IPTDS speakers, but only those in the auditorium. When it comes to other integrations, which is to say these gray ones here, the targeting is on the alert itself. You don't actually target in here. It's just already mapped, already known. And that's it. And that's the entire paradigm. You say, here's a message. I'm sending it out to an integration, whether native or using someone else's targeting. And if we're using air targeting on air side, we can use an entire laundry list of ways to determine it. There's been a lot of information. No one emergency manager will need to know all of it. So each one will only care about a small handful of these targetings. So let's just look at the broad strokes, which is this summary. There's a good chance that emergency managers already have some sort of system or multiple disconnected systems in place already. We have the capability to integrate with many other services to use their native targeting. Alertus Desktop in particular, there are damned near limitless ways to create targeting groups. Regardless of what system they're using, a device can be a member of many groups simultaneously. For instance, a device might be in the groups North Campus, Campus Safety, and Administrative Building, and would receive notifications based off of any of those criteria. Likewise, any alert sent from Alertus can target multiple groups simultaneously, such as North Campus, South Campus, and East Campus for the same flood warning. The most common configuration of Alertus is to use preset alerts, alerts that have their message, audience, and the way they are displayed all already saved. This cuts activation time down to seconds and allows many devices and endpoints to be reached simultaneously from that single point of activation. For IT, Alertus is just another program running over the network, and the idea of targets boils down to knowing what software needs to be pushed, to who, and what traffic will need to be allowed. They may also be responsible for setting up service level accounts to communicate broadly with other services. At first blush, this would seem like an overwhelming ask, but it's actually not as bad as explaining a jam to emergency managers. This is because IT is generally more concerned with the connections that allow targets to be reached than the actual ins and outs of the targets themselves. So let's get into how things connect. The easiest way to do this is to chunk out the devices on the chart and give you a general understanding of the scope and prevalence of each method. So here we have the structure of how we target devices. IP, or Internet Protocol communication, is used for the vast majority of communication to and from the Alertus server. This is the backbone that supports nearly all other communication. You can see this will cover desktop alerting, text-to-speech, VoIP, and all traffic to the web console and the Activator app. Most everything here will be HTTPS over 443 or 8443. If there's a service that already has a standard port, like LDAP uses 636 or 389, or if you use an email, expect 25 for SMTP. We use those standard ports for standard connections. No reason to give anyone a headache. The Alert Beacon is a bit of an odd duck, though. It uses IP, but it uses port 80, which normally would not be encrypted, but we use a pre-shared key. Also limited to 10 megabytes per second to connect the server. This is just so when you have the conversation with someone on targeting, they don't lose their mind on figuring that out later. Several devices that connect to the server via IP traffic extend their reach by interfacing with other devices. This is done via two types of physical connections. The RS-232, which you can see over here and down here, or also known as the DB9 or serial connection. If you owned a printer in the 80s, it's that cord, allows for sending serial information. This is a physical connection that was once used for printers and is still handy today for transmitting manageable text information. It's useful for sending the text print out of fire panels, LED marquees, and cable TV overrides. And we add air signal wires here. Signal wire is considerably simpler for an integration. It's a binary on-off connection that attaches to alert beacons and TTS devices. These are useful for monitoring panic buttons and access control systems, or for triggering and controlling your sirens and strobes. Here we've got air radios and pagers, just commonly used for one of two reasons. One, that the network is spread over such a large area that IP infrastructure would be more expensive than setting up a radio. And second is to be used as redundancy for IP infrastructure. In this case, pagers using a radio frequency, as they do, going from your normal system as a redundant means of targeting alert beacons. Generally, shortwave radios are used to extend network range, and paging integrations are used to supplement redundant methods. And finally, we have cellular, as you can see right up here. Cellular is an interesting extension here because it uses infrastructure outside of air direct control. The only current application of cellular technology is their mobile push notifications through the recipient app. Main take home from this is that the general shape of the Alertus solution is almost exclusively IP based here, but depending on the client's needs, the network can extend into other forms of communication. Again, the important word there is extend into. It is based in IP. Not every solution will use every form of communication, but almost without exception, every solution will be reliant on the IP traffic as the central structure of communication. So IT, when you're explaining this to them, is to say, hey, we're using almost exclusively IP traffic unless there's a specific integration that asks for otherwise. If they say what ports and protocols, you can say standard HTTPS, and if alert beacons, HTTP. We use 443 for air general communication over the web console, 8443 if we want air Alertus desktops checking in over secure rather than the unsecured 80. Again, they're using pre-shared keys. It's more secure than it sounds. Even when we're integrating to other networks and other services over REST APIs or SOAP APIs, we're still generally going to be using HTTPS for REST. If you're doing SOAP, you'll use 80, but we use that very seldomly. You can also let them know that any standard ports, like for mail servers and LDAPs, we just use the standard ones. And this brings us all the way back to the beginning. A big idea of targeting is comprised of three perspectives that radiate out in scope. Filling in the gaps refers to our native products that are easy to target. Integrations refer to the way in which IT will connect us to other native platforms. And a single point of activation will encompass both. Expressation has really been nothing but circles inside of circles, all expanding on the same idea, but connected to a single point. We look at that, a symbolic representation of this knowledge that is ubiquitous in the environment where it would need to be recalled. How convenient is that? Exactly. All right, y'all. I have been Brian. I'm your senior technical training specialist. This is where we open up the floor to questions, comments, concerns, heckling. Tell me about your weekend plans. Whatever you want, I am here for it. Happy Friday, y'all.
Happy Friday. Thank you.
You
Yeah,
are
happy
more than
Friday.
welcome. So, anyone got anything they want to cover in more detail? Any individual client situations or scenarios that you want me to go into some depth on? I am here at your disposal.
Really appreciate it, man. Thank you again.
You're welcome. Always happy to help.
We work together, so I'll just ask you every day.
Yeah, don't worry, man. I got you.
Thanks, All right, man. I'm out. Have a good weekend.
Have a good weekend, guys.
Thanks, Brian. I appreciate it.
All right, y'all. Have a good one.